Gravity. It's a word we hear often, but what does it actually mean? Simply put, gravity is a force that pulls everything towards each other. It's why apples fall from trees, why we stay grounded on Earth, and why the moon orbits our planet. We can't see it, but we experience its effects every single moment of our lives. Without gravity, our world would be a very different place. Imagine trying to pour a cup of coffee without gravity. It would be a messy and chaotic affair. Think about jumping up. You go up, but you always come back down. That's gravity pulling you back to the Earth. It's what keeps our atmosphere from floating off into space and plays a crucial role in the formation and behavior of stars and galaxies. Gravity is a fundamental force that shapes the very fabric of our universe. We often take gravity for granted, but it's a powerful force that impacts everything around us. From the smallest particles to the largest celestial bodies, gravity governs the interactions of objects across vast distances. And while we may not always be aware of its presence, gravity is constantly at work, shaping the world around us in countless ways. For centuries, people wondered why things fell to the ground. It was Sir Isaac Newton who, in 1687, revolutionized our understanding of this fundamental force. Legend has it that Newton was sitting under an apple tree when he saw an apple fall. This simple observation sparked a profound insight. There must be a force pulling the apple towards the Earth. Newton called this force gravity and developed a mathematical law to describe it. This law, known as Newton's law of universal gravitation, states that every object in the universe attracts every other object with a force that is proportional to their masses and inversely proportional to the square of the distance between them. This means that the more massive an object, the stronger its gravitational pull. Newton's discovery was a major breakthrough in our understanding of the universe. It explained why planets orbit the sun and why the moon orbits the Earth. It also laid the foundation for future scientific advancements, including Einstein's theory of general relativity. Newton's work transformed our understanding of the cosmos and paved the way for modern physics. Earth is much bigger and heavier than the moon. This means that Earth has a stronger gravitational pull than the moon. The gravity on Earth is about 6 times stronger than the gravity on the moon. This is why astronauts can jump much higher on the moon than they can on Earth. If you weigh 100 pounds on Earth, you would only weigh about 16 pounds on the moon. This difference in gravity also affects the weight of objects. A rock that weighs 10 pounds on Earth would weigh less than 2 pounds on the moon. The moon's weaker gravity is also why it has a very thin atmosphere. The moon's gravity is not strong enough to hold onto a thick atmosphere like Earth's. This is why astronauts need to wear spacesuits when they are on the moon. The spacesuits provide the astronauts with the air and pressure they need to survive in the moon's thin atmosphere. Gravity is a fundamental force that shapes the universe. It holds planets in orbit around stars, stars in galaxies, and galaxies in clusters. Gravity is responsible for the tides on Earth. The moon's gravity pulls on the Earth's oceans, causing them to bulge out on the side of the Earth closest to the moon and the side farthest from the moon. Gravity is also what causes black holes to form. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes are formed when massive stars collapse at the end of their lives. Gravity is an essential aspect of our universe, playing a critical role in the formation, evolution, and interactions of celestial objects. From the falling apple that inspired Newton to the swirling galaxies that grace our night sky, gravity is a force that binds the cosmos together.